All right, antiderivatives. So when you're finding the derivative of, say, x to the n, this is going to result in n times x to the n minus 1. Now the antiderivative is the opposite. So x to the n results in x to the n plus 1 divided by n plus 1. And we're also adding in c because it's a constant of integration. Now this c is added because when you take the derivative of a function, the constants are completely go away. So when we're trying to take the antiderivative, almost undoing that derivative, we get a function without a constant, so that's what this c accounts for. Now, to show what this looks like, we have the antiderivative of x to the power of 3 dx. Now, this is going to turn into, so x to the power of 3 plus 1 over 3 plus 1 plus c, which is going to equal x to the power 1/4 x to the power 4 plus c. Now, what you'll notice is if we take the derivative of this, that's going to equal 4 times 4. We subtract 3, or 1 from 4. That's going to equal to x to the power of 3. And this c is a constant, so it goes away. Now, if we're taking the derivative of cosine, let's say cosine of x plus sine of x dx. Well, you do the exact opposite as if you were taking the derivative. So when you find the derivative of cosine, that would be negative sine. But the antiderivative of cosine is equal to positive sine because the derivative of sine is cosine. So this is going to be equal to sine of x minus cosine of x, because if we were to take the derivative of cosine, we get negative sine, and negative cosine, the derivative of that will be positive sine. So we have to account for that addition plus c. Now, if we were to find the derivative of this, it would simply be equal to sine or cosine of x, as you can see, sine of x plus sine of x. We just did the opposite of what we would do to find the derivative. So what function would we take the derivative of to get to this? It also works with, say, secant squared. Well, what of x dx? That would equal to tangent of x plus c, because the derivative of tangent is secant squared, and that is antiderivatives.